Rational exponents. Definition: b to the 1 over n with a slash sign, or b to the 1 over n with a fraction sign. So for counting numbers n, where n does not equal 1. If n is odd, then b to the 1 over n is the number whose nth power is b, and we call b to the 1 over n the nth root of b. If n is even and b is greater than or equal to 0, then b to the 1 over n is the non-negative number whose nth power is b. We call b to the 1 over n the principal nth root of b. If n is even and b is less than 0, then b to the 1 over n is not a real number. b to the 1 over n may be represented by the nth root of b. So in a sense, rational exponents, in this case 1 over something, implies that it's a root, but in exponential format. Square root is one of those examples. Cube root, fourth root, etc. So even though in this case they're talking about as well the principal root, principal just means positive side. In many cases we see both positive and negative side. And as you've noticed, in some cases there are some non-real solutions. So let's start with b to the 1 over n as a fraction sign. It makes it easier to visualize. Keep in mind, the 1 over n is an exponent. So we make it smaller and higher than the base, the v value. Likewise, we can rewrite it with exponential format to square root format. One thing that I helped or used to help myself remember is I asked myself, what do trees have? Whoop, said it backwards. Root, right? So whenever I forget, we have bases, two exponents, that can be converted into roots, right? Square roots, to be more precise. Okay, so for instance, as I've previously mentioned, we can use square roots as an example. Square roots is one of those examples that can be written as exponential format. Do notice though, square roots, we typically don't write a 2 on the radicand, or your radical sign. Your square root sign is called radical sign. So square root. So normally we write it, but without having to write a 2. If you see a square root, it implies that it's a second order or a square root. So we normally don't put a 2 on there. Once again, notice they're the same, okay? We have cube roots, which we typically do have to write a 3 on there. Similar to what's shown there. Anything other than a square root, you have to show what root number you're using. Such as fourth root, you have to write a 4, fifth root, a 5, etc. So any other root other than 2, you have to write the root number that you're trying to use, okay? So, once again, need to show for all other roots except for the square root. We don't need to show it. So b to the 1/2 is the equivalent as a root format, or exponential format, I should say. Square root or b to the 1/2, or 1/2 power. They're equivalent, so we can call them equivalent, or they're equal, or they're the same technically, but different form of writing it. So one example is, for instance, 25 to the 1/2. That implies that we have a square root of 25, but this is an exponential format. Try to get used to it, it helps out. So let's rewrite it as a square root, just for visual in this case, but in many cases in the future, we won't write it with a square root. We'll just say it's a power of 1/2, or power of 1 over something. So square root of 25, what number times itself twice gives you 25. That's essentially what a square root is, right? What number is that? 5? Yeah. If you multiply 5 times 5 gives you 25. But not only that, what happens when you multiply -5 times -5? -5 times -5 is still 25. Negative times a negative still positive 25. So for even roots, even number roots, we have to use a plus or minus. So anytime you have an even root, even number root, you have to use a plus or minus. So exponential format, same idea still holds. You need a plus or minus for even roots, or even exponents, exponential root formats. So another example, 27 to the 1/3. We can rewrite this as a, well, it's an exponent of 1 over 3. The root would be 3 if we write it as a square root, or I should say cube root, not square root, right? This is equivalent to saying cube root of 27. 27 to the 1/3, cube root of 27 are equivalent. So, and by that, we can see that it's 3. If we multiply 3 times 3 gives us 9. 9 times 3 is 27. So you have to multiply the 3 times to get 27, in other words. Notice we don't need a plus or minus in this case. Our root is a odd number root. It's 3. So if it's a 3, 5, 7, 9, 11, etc., all odd number roots, do not need a plus or minus. Even number roots, as is 2, 4, 6, 8, etc., do need a plus or minus. So in this case, our answer is exactly 3. And let's notice we can probably rewrite this as well, the fourth root, as b to the 1 over 4, just for reference. And once again, root format, fourth root. We have to show 4. Okay, and then your number, you need a plus or minus on your answer. Whatever the number is, you will need a plus or minus, because it's an even number root. It's a 4. And once again, just for reference, 1/5, equivalent as a root, is fifth root. So b to 1 over 5 equals the fifth root, and whatever number you choose to take the fifth root of. This number does not need a plus or minus because it's an odd root. So you get exactly what you need from odd number roots. Even number roots, you need a plus or a minus. And ask yourself, does it make sense to have a plus or minus depending on what you're talking about?